Hi everyone, in this video we're going to go through writing equations of medians and perpendicular bisectors in triangles. As far as segments and quadrilaterals, that's something that we're actually saving for the next video section, so don't worry about that. Okay, so medians. This is something that we've learned about before in a triangle. The median of a triangle is a segment drawn from a vertex to the midpoint of the opposite side. The point of concurrency of the medians is called the centroid. Okay, so before I move on to that next part, I'm just going to sketch a little triangle up here for this visual. You guys actually did this for homework once before, where you had to locate the midpoint of a side using a perpendicular bisector, using your compass and straight edge. And then we join that midpoint to the opposite side, and that's your median. Okay, and then I'll do this in another color. If I were to do, let's say, another median, so again, that's a midpoint joined to the opposite side. That point of concurrency is known as the centroid, and the centroid divides the median in a ratio of 1 to 2. So that should sound familiar to you guys from what we talked about at the end of Unit 8, I believe, / beginning of Unit 9 is where we talked about that. Yes, it was the end of our similarity unit. Okay, so then moving on to our next little section here. We also talked about perpendicular bisectors. A perpendicular bisector is a segment which is perpendicular to a segment at its midpoint. The point of concurrency of the perpendicular bisectors is called the circumcenter. And this is something that we actually covered back in Unit 1. So if I were to sketch a little picture here, there's your triangle. Okay, perpendicular bisector starts off similar to median, where you locate the midpoint, but then it doesn't go through the opposite vertex necessarily. It goes perpendicular up. So just based on how I drew my triangle, that's what my perpendicular bisector would look like. And then if I did another one, okay, let's say that one's the midpoint and I went perpendicular, you can see that my point of concurrency is located right there, where I kind of darkened it in with my brown pen. Okay, so putting this into some context with the coordinate grid, let's say I have a triangle. This says PQR, but really it's ABC, so excuse the little typo there, where A is at 2, -8, B is at -4, 6, and C is at 8, 6. I want to write the equation of the line containing the median drawn from vertex A. Okay, so again, median is when you find the midpoint and then you draw it to the opposite vertex. In this case, they're referring to vertex A, which then would mean I want the midpoint of BC. Okay. So I'm going to locate the midpoint of BC, and you could either use your midpoint formula or just count it out. Our midpoint is going to end up being at 2, 6. Okay, let me zoom in here real quick. Okay, that should look right. It goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So again, you can either use the midpoint formula, or I'm just using the grid there because it's an easy little horizontal line for me to locate it. Now this one actually works out pretty nicely because as soon as I draw from the midpoint to the opposite vertex, you can see that that is a vertical line. And vertical lines are some of the easiest lines to write because that's when I think VUX, which means it's an x equals equation. So again, I located the midpoint of BC to be at 2, 6. I know that this is a vertical line, so I start thinking VUX, which means x equals. I can see x is going through 2. So x equals 2 is the equation of our line. So whenever you have a horizontal or vertical line, you're not going to be rewriting that with point slope form. You're simply just using Hoy or VUX. All right, let's do the next one. Write the equation of the line containing the median drawn from vertex B. So if we're going to go from vertex B, that means I'm looking to the opposite side, which is AC. So I need to find the midpoint of AC. Now, since this is a diagonal line and it might not be as easy to pick out on the grid, I'm going to actually use my midpoint formula here. So I know that the coordinate of A is 2, -8, and I know the coordinate of C is 8, 6. The midpoint formula is the average of the x's and the average of the y's. Okay, so 2 plus 8 is 10, divided by 2 is 5. Then this would be -2/2, which is -1. Now, just to help keep things a little bit more consistent for you guys, so I can label it clearly, let's just call that M on my grid. So that's at 5, -1. So 1, 2, 3, 4, 5, -1. I'm just going to call that M for you guys. Okay. So, oops, sorry about that. Now what I have to do is take that midpoint and draw the line back to the opposite vertex, which again we've defined as B. Okay, so for step 2, anytime we're writing the equation of a line, we're going to want the slope. So I'm going to write the slope of BM. So you can see that's why I called this M, because then I could nicely write this out for you guys in my work. So I can apply the slope formula to make my life a little easy, or you can count rise over run, but I'm actually going to do the slope formula just because I want to make sure I don't accidentally count wrong. So B is -4, 6, and M, which I just identified, is 5, -1. So slope is change in y over change in x. So I'm doing 6 minus -1 over -4 minus 5. Okay, so that simplifies to 7 over -9, and that would be my slope. Now, if I actually counted here from B to M, I bet I actually do go down 7 and to the right 9 exactly, because that's not really a nice number that like reduced. I remember students in the past thinking that it was something different, like maybe they counted wrong by accident. So let's see, if I go down 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that it's rise over run. It's -7 over 9. Okay, and it's negative because it's falling from left to right. I've had students in the past think it's -2 because they think that these are going nicely at those little intersections, but they aren't. So if you are going to count rise over run, actually go from B all the way over to M, just to be certain. Okay, and then lastly, we just need to put it together. Now, as far as the equation, I'm going to use point slope form, and I'm going to do the equation through B, because it said through vertex B. And I'll talk about another solution after the fact. So the equation of B, or through B, where B has the coordinate of -4, 6, would be if I use the formula y minus k equals m times x minus h, where again, h and k is coming from the point, and m is coming from the slope that I just found. Okay, so I have y minus 6 equals -7/9 times x plus 4, and you're done. You do not have to simplify that. This is your answer in point slope form, and that's the equation of your median. Now, I said that there's technically another solution here. You can see that I deliberately chose an equation through point B because it told me to go through vertex B, but technically I could write an equation through point M, and that would look like this. So M has the coordinate of 5, -1. So if that's h and that's k, this would be y plus 1 equals -7/9 times x minus 5. So you see that I just have a different point plugged in here, which is 5, -1, but the slope is the same. okay? And that's because those are 2 points on the same line. So technically either one of those is the same, or either one of those is acceptable. Now, if you were to put either of those into slope-intercept form, you would actually find that they're the same. Now, chances are, if you're looking at an answer key that I would do, I like to do just the point that they tell me first. But again, I wouldn't take off if you did point M, because technically that's also a point on that same line. Okay, we got one more to do. And you guessed it, it's the median from vertex C, because that's the only one that's left over. Okay, so again, I'm going to write out my steps here. If we are going to go, I'll zoom out here for a second. If we're going to go from vertex C to find the median, that means we need the midpoint of the opposite side, which is AB. So midpoint of AB. Okay, so again, I'm going to do the slope formula. So A is the point 2, -8. B is the point -4, 6. And midpoint is average of the x's, average of the y's. Okay, so this goes to -2/2, which is -1, and -2/2 again, which is -1. Now, just like last time, I'm actually going to call this n so that I can easily identify it on my grid. I'm actually going to use pink to try to keep everything separate here, so you know where my work's coming from what. So there's that. Oops. -1, -1. Let's call that n. Now, if I want the equation of the line, or the median from n, so to the opposite vertex C, that's what my line would look like. Okay, so then next, I got to find the slope of that line. So I'm finding the slope of NC. Now for this, just to show you how I can do rise over run, I'm going to zoom in here. Okay, I'm going to go actually from N to C. So I'm going up 1, 2, 3, 4, 5, 6, 7. And I'm going over, so again, that was up 7, over 1, 2, 3, 4, 5, 6, 7, 8, 9. And that was over 9. So that's my rise over run slope for NC, so 7/9. I'm actually just going to write 7/9. Okay, so then lastly, I'm going to write the equation through C, which has the coordinate 8, 6. So again, using point slope form, y minus k equals m times x minus h, where this is your hk. See if you can come up with the equation. So I would say hit pause, and then unpause when you're ready, and I'll reveal the answer. Okay, so using that point C, which was 8, 6, and using a slope of 7/9, this is your point slope equation of the line. Okay, now, like I said before, this is chances are what I would have on an answer key, but technically you could have also used the coordinate n here, which would then just change those parts right there. So just so that you're aware, I'll write that second option, or again, your point n was the coordinate -1, -1, so that's y plus 1 equals 7/9, x plus 1. But like I said, I try to use the point that they actually had here, because if I accidentally got this point wrong or something, I'm at least going through point C. So just something to think about. All right, so our last page, again, we're going to do perpendicular bisector. I know I defined this on the previous page, but we're going to define it again. A perpendicular bisector is a line, segment, or ray that is perpendicular to a segment, and it intersects the segment at its midpoint. Okay, so triangle PQR has the coordinates, oh my god, PQR, so silly. DEF, it looks like, has the coordinates 3, 5, 3, -1, and -5, -1. Write the equation of perpendicular bisector DE. Okay, so the perpendicular bisector of DE means we're going to find the midpoint of this segment and then go perpendicular to it. Now, you can easily just count on the grid here where our midpoint is. I'm going to zoom in a little bit. Okay. 1, 2, 3, 1, 2, 3. Yep, so this is our midpoint. It's located at the point 3, 2. Now, this line, DE, has a slope of 0, or has an undefined slope, excuse me, which means perpendicular to it has an undefined slope, which is a horizontal line. So again, we're not going to do point slope form here. We're going to use just the fact that this is a horizontal line, so we should be thinking hoi. So again, the first thing I did was I found the midpoint of DE, which was the coordinate 3, 2. 3, 2. That's your x, that's your y. But this is a horizontal line now that we're drawing, which is our perpendicular bisector. So we're thinking y equals. So that means y equals 2. Because of that is going to be the equation of our line. And that's because every single point on this line that I have created has a y coordinate of 2. Okay, then we'll do the same thing for EF. So EF is down here. If I had to locate the midpoint, I think it's right there. Let's see, 1, 2, 3, 4, 1, 2, 3, 4. It is. And that midpoint is at -1, -1. Again, you're going perpendicular now to that segment, which as you can see is a vertical line. So the midpoint we identified was -1, -1. So it actually works out pretty nicely. It's a vertical line, so I'm thinking VUX. So not that it makes much of a difference here, but x equals -1 is our solution. The reason I said not that it makes a difference is because these coordinates are the same, but obviously you need to know VUX, we're doing x equals. These just happen to be the same coordinate. Okay. Now's the harder one. Write the equation of the perpendicular bisector of DF, which is this dude right here, and state your answer in AX plus BY equals C form. Okay, so just like in each of these scenarios prior, I'm going to locate the midpoint of the segment that they've given me. So first step, I'm going to locate the midpoint of DF. So I know D has the coordinate 3, 5. F has the coordinate -5, -1. I know the midpoint is the average of my x's and the average of my y's. Okay, so you can see that this would go to, this would go to -2/2, which is -1, 4/2, which is 2. So let's see where that is. So -1 and then 1, 2. Okay. So now what we're going to do is find out the slope that would be perpendicular to this, because we need the midpoint. Or we need the equation of the line from that midpoint. All right. So next thing I'm going to figure out is what is the slope of DF? Okay. So if I count rise over run here, this is up 1, 2, 3, 4, 5, 6. Running 1, 2, 3, 4, 5, 6, 7, 8. Running 8. Okay. Sorry about that. Okay, so our slope is rise 6, run 8, which I'm actually going to reduce to 3/4 because chances are you would see it in a reduced form. Now, since we're going perpendicular to that line, we need the perpendicular slope. As we know, perpendicular slopes mean negative reciprocals. So -4/3 would be that slope. So essentially what we're saying is, from this point, if we want to draw a line that's perpendicular, we're going down 1, 2, 3, 4. 1, 2, 3, 4, running 1, 2, 3. And that would be the next point on that line. So I'll actually even use a little straight edge here and draw that so you guys see. So that's my line essentially. Okay, so now here's the good news. We have everything we need. I have a slope, and I do have a point that I know that is on this, which is the midpoint of DF. So there's my slope, there's my point, so I just got to plug it into point slope form. So it's step 4. I'm doing, again, the equation, but through the point -1, 2, because I know it has to go through that midpoint. So this is y minus k equals m times x minus h. Okay, our point is again -1, 2, so this is y minus 2 equals, my slope is -4/3, and then x plus 1 puts it into point slope form. Okay, so as you can see, it's a lot more involved when we're doing the perpendicular bisector of a segment that's diagonal. When it was horizontal or vertical, it was pretty easy. Okay, so again, taking you through the steps, we found the midpoint of the segment, which was here. We found the slope of the segment. We found the negative reciprocal slope. And then we wrote the equation of the line using point slope form. Now, this problem says we want to put it in ax plus by equals c form though, which is not the form that it's in right now. So what I'm actually going to end up doing is trying to reduce this fraction right here by multiplying through by 3. I just want to clear out some fractions. So if I multiply through everything by 3, okay, this would be 3y minus 6 equals -4. And then that -4 would end up multiplying the x plus 1. So because I'm multiplying the 3 by the -4/3, which would then in effect multiply the x plus 1, you're not distributing anything more than that. Okay, so sometimes I'll have students just try to distribute to the x and the 1. You're not doing that here. You're taking care of that in this first step. Okay, now I'm going to distribute that -4. So this is 3y minus 6 equals -4x minus 4. And then I just have to put it in ax plus by equals c form. So that involves taking this 4x and adding it to the other side, and moving that 6 over to the other side. So essentially what we come up with is 4x plus 3y equals 2. And again, this is ax plus by equals c form, where a is positive. So this is perfect. Okay, and that's our form that we can write. Now, oh, and something else I'll mention is that, something else I'll mention is that you'll notice also that A, B, and C are all integers. They are not fractions. If they're fractions, then it's technically not in that standard form. Okay, and that's why when I chose what I was going to multiply this equation through, I didn't say, oh, let's multiply through by the reciprocal. I just multiplied through by a denominator that I know would clear out that fraction. So in that case, 3. Okay, because otherwise then I would have created more fractions in other places that I'd have to eventually get rid of. So just make sure you guys know the difference between each of these types, which I have summarized down below. So median and perpendicular bisector are the ones we just covered today, and altitude was in a previous video. Okay, median is where you take the midpoint and you draw the segment to the opposite vertex. Perpendicular bisectors where again you locate the midpoint, but then you're using negative reciprocal slopes to write the equation of your line, or in this case, it looks like just a vertical line, so VUX, so be aware of those scenarios where that happens. And then lastly, altitude, where you're going perpendicular to the opposite side, but it's not necessarily through the midpoint. Okay, so I hope this video helps. If you have any questions, reach out.